Hey there, welcome to ADHD Engineering in Depth. This is my second channel where we're going to do live streams. And I also wanted to have a place where I could do some longer form, more detailed content. I have personally learned a lot of different stuff on YouTube because people were willing to put up kind of detailed content with some practical hands-on stuff. And a lot of times the mainstream YouTube content, they skip over the gory details of how something is built or how something is done. And because I have benefited personally from watching some of that longer content, I wanted to be able to pay into that font as well. I don't expect a lot of people are going to watch these videos, but if you do and you find what I'm showing you helpful, then that's why we're doing it. So second channel will be live streams and more in-depth hands-on projects. And today's project is the first one of those. And what we're going to do is we are going to make some tables. And we're going to build these tables ourselves. I can't find really what I want. And what a normal person would do in this case would be to hire a carpenter to make some tables. Now, I have a micro factory. I run it's a makerspace. It's a very well-equipped makerspace. I'm not hiring somebody to make this stuff when I can make it myself, especially when I can make it for cheaper than the retail price. And let's look at this. So the tables that I'm going to make are these 8-foot tables. They're going to be 8 foot wide. I have about a 4-foot aisleway here, and I want to have 4-foot sections so someone can sit on all the 4 sides of this. And between these two tables, we have 8 workspaces. They need to be heavy duty because people are going to be doing some engineering type projects on them, building stuff on them. They need to have a lot of power outlets, and they need to be sturdy. And so, you know, when I was looking, said, could I find an appropriate piece of furniture like this? I looked at this is probably the closest I found to what I wanted. This is an 8-foot table, but it's not in stock. It's about $1,000. And it got a couple ports for electrical outlets, but not really. If you wanted to go cheap, this is the cheapest I could find. This is an IKEA table, which is definitely cheaper, much cheaper, but it's too big. It actually does. If I was to get 2 of these, it would protrude into the aisle that I'm trying to leave here. So it's actually too big, and all the other IKEA tables are too small. The other option would be something like a U-line packing table. And these things are robust, they're heavy. This one's the right size. It's I would need 2 of these back to back, but if you look at this, for 2 of these back to back, it would still be $800, and I don't like the look of these legs. So we're going to design exactly the table that I want, and I've already done a little bit of the background work here. I know that I can design what I want. I can do it for less than I could buy something commercially, and it's going to be exactly what we need. So with that, let's jump into Solidworks. What we're going to do, the approach here is that we are going to have an assembly with 2 major parts. One, I'm going to draw the tabletops just so we can locate everything. And then underneath it, we're going to do a 3D sketch, and we are going to define a welded steel frame underneath it. And if you are not familiar with SolidWorks and the Weldments feature in SolidWorks, this is like my favorite thing to do. So let's dive into it. All right, so let's jump in, and we are going to do our first sketch. We'll start with a midpoint line. There is this design. I'm using 2 maple butcher block countertops that are from the Orange big box store. And there's going to be a 5-inch gap between the 2. They are 2.5 feet deep and 8 feet long. All right, so there we have our 2 different countertops. These are kitchen countertops. I'm using them as desks. The reason why I have them offset here is that I want there to be a gap in the middle for a big power strip. And this power strip is going to be recessed. I don't want it to be hanging up on the top. I want it to be kind of down in the middle, and I want it to be open on the sides. Every single time I have found a table where there is like a well in the middle for the power supplies, there's always like 5 years of like potato chips in there. So I want it to be that that there is a recess, but it's open on the side. So the cords can come in, they can come out, doesn't really matter. I have these two different things. These are prefab kitchen countertops. I've already bought them, but there's also going to be a insert of material right here at the end. Let's say that is 2 feet long. Because this on the right side here is where people are going to walk by. So on the left side, there's going to be a computer monitor over here. That's going to be on an arm that can swing out this way or this way. And on this side, there is going to be basically 1, 2, 3, 4 different work surfaces. Now, this is a sketch that I've done in the assembly. It's not a part sketch. This is a layout sketch within the assembly. I've laid out the tabletops, and I'm going to give it just a few different indications of where I want the feet to be. And to do that, I'm going to add some center constraints and mirror these parts across these center lines. I have a general philosophy, which is that you should never do with a dimension that which you could do with a constraint. So where the edges of the legs that are going down out of this are going to be, those are going to be 3 inches away from the edge, both in the horizontal and the vertical plane, the way you're looking at it right now. And instead of dimensioning these points to every single line, I'm instead going to take a point, select a midpoint, select the other point, and give them a symmetric constraint. That way, there's only one set of coordinates, and if I wanted to, I could change this dimension up here, and it would change all of the dimensions. So again, that's cardinal rule in my book is if you can figure out a way to not use a dimension, you should do it. That served me pretty well. All right, so now this sketch is finished. This is our layout sketch. It's part of the assembly. It's not a part. So now that we have done the layout sketch, we're going to add a new part. It's going to have to save it. Now, by the way, this is SolidWorks connected. So if you see this part up here in the corner where it says Inventopia, there are multiple 3D workspaces. I found out the hard way that unless you are already working in the right 3D space in that selection drop-down up there, you can't select where you're going to save stuff once you've opened the save file dialog. You have to already be working in that space. So something to look out for. Not necessarily intuitive. All right, now SolidWorks always defaults to saying, hey, put a sketch someplace. And so it wants you to select a sketch, but we're not going to start with a sketch. We're going to exit that sketch because we want a 3D sketch. So we have to exit out of that first. And what I'm going to do is I'm going to use these leg points that I've already defined. And in a 3D sketch, it defaults to one of 3 different sets of planes. Here it's in the XY. If you hit tab, you can change the default set of planes you're going on. Here, you see it wants me to shoot it off this way. I hit tab, and now I can shoot off this way. And now I want to go back into the vertical plane and meet up with that one. This doesn't look right because it can't anticipate what I'm trying to do. But nevertheless, I can collect that guy and say, hey, you are going to go in the Z direction, and you are going to be, so this table, by the way, is going to be 32 inches tall, but we're going to subtract from that 32 inches because this is the frame that goes underneath it, 1.5 inches for the thickness of the table, and we're going to put leveling feet on the bottom, and I would say we should give them a 3/4 of an inch. So we're also going to subtract 0.75 inches from that, which means that, and if I'm in millimeters, I haven't even set the native units for this sketch, but either way, it does it just by itself, which is fun. Again, since I have the layout sketch here, I don't have to measure where these origins are. These are the legs that are going to come through, a lot like this table here, except mine's way wider, and it's just the way I want it to be. Now, one of the cool things that it took me a while to figure this out, and when doing 3D sketches in SolidWorks, but once you figure it out, it's amazing, is that it always gives you this little triad of axes down here where the X, Y, and Z sketches are. And in this case, I could have this dimension, or I could tell it that these two, in order to constrain this line and give it the right length, I could tell them that those two are equal. That's an easy thing to do, right? But there's a lot of places where you can also do things like this. Like those two different points are going to be in the same line. They're collinear along the x-axis. So I could also tell it that that is along x. This may not be the best example of it, but when you can start thinking about which line should be heading off in one of those kind of orthogonal directions, very powerful. All right, so here we have, let me turn off this sketch. So the first sketch, that was my layout sketch. This sketch is the 3D sketch for the welded frame. You can see I have a little bit of an extra member over here to support the closed end of the U. I'm also going to add a vertical member here for a monitor stand. But the one thing that you'll see why I'm doing this in a second is that I'm going to add a floating line in here hanging out underneath this, which is going to be a member that we actually attach the power strip to. That'll be below the main surface of the table and kind of floating underneath. All right, so now I have my monitor arm. And if you look at it, this will make sense in a second. There's one line for each of these members, but when you are doing the weldments, you pick which corner of this square tube. I'm using square tube in this case. You can do it with rectangular tube or whatever shape, but you're basically doing a profile sweep around all of these lines, and you get to pick which corner you're using. Now here, there's a lot of entities that are sharing this point, but I've already thought through in my head, and I'll show you in a second which edge of the structural member I'm using. So it does help to know, have the end in mind so that you can sketch these things easily. This was the easiest way to sketch this, but I'm going to get away with it because I've already thought through how these weldments are going to fit together. So now is where we do my favorite part, where we add in a structural member. These are going to be 2-inch tubes that are square. I already have a profile in SolidWorks by default that's a 1/4 inch thick 2x2 tube. We're not going to use 1/4 inch thick tube. That's way too heavy, but I can edit that, and I'll show you that in a second. We're going to make a few different little groups here, and with each group, you have the opportunity to tell it on which of these corners, which of these profile corners is going to line up with the line that I drew. And in this case, I want this blue line going across the top. I want that to be where the tabletop is. So I hit locate profile, and I pick this outer corner. Now it goes down here. I intended this is where the feet are going to be, and it's on the inside. Now I can hit a new group. The same member over here is exactly the same, except I need to pick the outside corner differently. All these legs are 3 inches in from the outside of the table. So same process, I just have to pick a different point in that profile. Here I want to pick this outside corner in order to make it work. And now this is 3 inches in from the outside. I did those two first because it's going to give them trimming priority when I do the next things. New group, I grab this guy, and you see it, by default, there's a center line, and so it would go through this other member, right? But nope, that's not what I intended when I drew that. I intended that it's going to be aligned with this corner. That gives me the ability to weld these two together right there, weld these two together right there. You get the picture. Now more profiles. Now you notice each of those is done as its own group, and each group, every time you pick another set of members where you need to line up the line with a different point, you need to have a new group. So all of those, when I edited this this part, these were all, I now have 5 different groups, and there's now only one left, which is the support that goes underneath. And this one's going to be just a little weird looking because it's not actually supporting the tabletop. This part is supporting the power strip that goes underneath everything. I'm going to align that to that one. Again, it's going to line up so that I can weld it into place down here and up here. And I can weld it to this cross member over here. And the power strip will just be sitting on this beam. So that's it. We have our weldment frame for this table already done. We're going to insert a new part that is going to draw the tabletops just so that you can see what that looks like. And then we're going to come back to the weldment. We're going to do a cut list so that we know how much steel we need to buy. But first, I told you we can change the wall thickness. So let's do that. Right now, this dimension here is 2 by 2 by 0.025. If you open up this feature, there's a sketch in there, which is the profile that is being used to make all these things. You can edit that directly, and it'll bring you so that you're normal to it. All right, this is, again, still we're set to millimeters, but this is going to be 0.065 inches. And this outer dimension here, 0.125 inches for that radius. That gives me a lightweight square steel tube, much more like what I'm expecting to buy. All right, now we're going to do the tabletops. Because I've already done a layout sketch in the assembly, this part is super easy. I'm going to show that layout sketch, and then I'm going to basically trace over where those tabletops are going to be, extrude them up, going to add color to them so you can kind of show the look I'm going to have, and then we're going to have a model of pretty much the finished product here. So check this out. All right, that is all 3 pieces, and I'm going to extrude the 3 different pieces of wood using this same sketch. The only thing to be careful with here is that I do not check this merge result button so that this stays as its own body, and that will allow me to assign a different texture to it because I want to have that be a slightly darker wood. All right, and now we're basically done. I just have to turn off the sketches here, and that's pretty much our table. Oh, I did make a mistake. I didn't select this part when I extruded these guys, so there's a slot there. But this is essentially our table. We have a tube underneath that's going to get welded in. You see there's a gap underneath here. The power strip is going to be one long multi-outlet power strip. Will just get zip tied down to that, and I'm going to drill and tap a monitor arm mount that will have a one of those 2-arm swinging monitor things. I'm going to buy that later. I'll probably have this be a little longer. I can always cut it down, but we'll be able to have a monitor on this upright, and that's exactly the table I need. Not a big deal in terms of design. Fixing this is just as simple as making sure that I've selected the right regions. All right, so that's fixed. Here is my table. Now we're going to figure out, is the price right? And the way we're going to do that is by opening the weldment part here. I don't care about the tabletops. I've already bought those. The weldment part here, these legs, I'm going to open that and then make a drawing out of this part so that I can use make a drawing from this part and then make a cut list in that drawing. And then I will have a guide that will tell me exactly how long each piece of metal is. We're going to do some math on it. You'll see me edit a table to have the cumulative length and then sum all those up, and then we'll know how much metal we need to buy for this project. One thing to point out here is that you saw that I changed the wall thickness of the tube. It knows the description. SolidWorks is smart enough that in the description, it was dynamically linked to that value in the sketch. So it knows that the thickness is not 1/4 inch already. I think that's super cool. All right, now you can see that this is a cut list. It's just like an Excel table. It's not as easy to use as Excel. For example, I wanted to multiply the length in inches times the number of each of those cuts. And if you paid attention, I had to enter that that formula for every single cell. And in Excel, you can just make a formula and then spread it across a number of rows. I haven't figured out how to do that in SolidWorks yet. If you know how to do that, please tell me in the comments below. But either way, I was able to add that formula and then sum it up. I summed up the inches and then divided them by 12 to give me the feet. So I now know that in order to make this table, this big 8 foot by 5 foot table with the frame that I've designed here, I need 57 feet worth of material. Now, if I go to Online Metals, I'm going to find the same kind of metal stock. I can buy it in 20-foot lengths, get a relative price, and I'll plug those into my spreadsheet. There's only one part. This photo is not the correct one, but you can see the wall thickness is 0.065. I want to pick 20 feet long, 240 inches, and they are $68 each. If I get 3 of them, it's 204. So I'm going to plug that into my spreadsheet here. So iron is $204. The countertops, I already bought them. They were $225. So those are 225 times 2. So let's call it $450. And then we need to put some sort of value in there for what's my time worth. Even though I'm willing to do this for free, and a lot of times in a DIY project, you might be willing to say, I would pay for the experience of doing this myself. I still suggest you always put in a value for your time. So I think that I can do this. Maybe the stand will take 2 to 3 hours. It's not a lot of cuts. I have a good bandsaw. I have a good TIG welder. I think that with 2 to 3 hours for the base, the tabletops are already done. I just have to install them, screw into them, and finish them. So I say I'm going to put in 6 hours. I think that's pessimistic. But my time is worth, let's say 6 hours. And let's say that I'm charging $40 an hour. That's not my billing rate, but for the sake of if I was to hire a carpenter for $40 an hour to do this, I think that's the appropriate rate. So if you look at that, the sum of those 3 is really our project cost, or at least our rough project cost, $894. If you look at that for this furniture, I'm actually coming in below. The IKEA one was cheaper, but not the right size, so not an apples to apples comparison. And the Uline desk was going to be about the same price. So here we are looking at even building it ourselves, accounting for the time we're going to put into it. We can make a table that is exactly what we want, and we can do it probably for less than we could buy it in the open market if that product even existed. So this is a perfect DIY project, and this is something that we're going to do. We're going to tape the actual building of this. Hopefully the design is good enough that there's not any necessary large changes that have to be made in the future. I am aware that I haven't, in this model, I haven't put the feet in. I haven't cut any holes for where we're going to need access for screws to hold down the tops. I'll cover those in the video. Those are some details. What I wanted to get done in this video is show just really how easy it is to make something like this, welded frame table in SolidWorks. If you have these tools and they're accessible to you, you can do this in no time. And I think it's a lot of fun. So anyway, thanks for watching this. We'll be building this on this channel. We're going to have a live stream on Friday at 1 o'clock Pacific time, 4 o'clock Eastern. So join us for that. That's going to be a different project. That's going to be the music box for the marble machine. And I'm going to have some friends on with me live during that as well. So thanks for tuning in to ADHD In Depth, and I'll see you next time.